All right, so let's look at a few more examples of our parabolas. So again, we are going to analyze and graph the equation. X plus 4 quantity squared is equal to negative 8 times the quantity y plus 2. So first things first, we want to figure out the direction that our parabola is opening. So given that we have an x squared and we have a negative coefficient of our y, that's going to tell us that our parabola is opening down. Okay, and again, I'm just thinking about my formulas up here. So x squared and a negative coefficient on the y, our parabola is opening down. Okay. All right, next thing we need to figure out is what is the p-value. So I'm going to go ahead and rewrite this equation. So x plus 4 quantity squared. Remember, all of our equations have either a plus or minus 4 as a constant times p. So in this case, it's a negative 8. So we'll have a negative 4 times 2. Right? Negative 4 times 2 is equal to negative 8 times the quantity y plus 2. So we're always separating it out into plus or minus 4 times our p-value to figure out what will get us back to the given number. Okay, so that tells us then that p is equal to 2. Okay, one little note here, p is always a positive number. If there is a negative sign, it goes with the 4, not with the p. Okay, p is always positive. All right, let's figure out where our vertex is. So remember, the vertex comes from the h and k. So basically that comes from your factors. So just like any factor, you take the opposite of the factor. So with an x plus 4 and a y plus 2, our vertex is going to be at the point negative 4, negative 2. Okay, so the vertex is at negative 4, negative 2. All right, and we said that our parabola is opening down, which means the axis of symmetry is the vertical line that passes through the vertex. Okay, so that's going to be our axis of symmetry. Okay. All right, now let's find the focus. So remember, P tells us the distance from the vertex to the focus. So in this case, we're going to go 2 units down from the vertex to find the focus. So if we start at our vertex and go 2 units down, and we're going down because that's the direction that we said our parabola is opening, we can plot our focus. All right, so that is going to be at the point negative 4, negative 4. All right, next we need the directrix line. Okay, so that's just going to be in the opposite direction from the vertex. And remember, the directrix line is always perpendicular to the axis of symmetry. So since our axis of symmetry is a vertical line, the directrix line will be a horizontal line. So from the vertex, we are going to go 2 units up and then plot our horizontal line. All right, so since that's a horizontal line, that is going to be the equation y equals 0. All right, and then lastly, we need the latus rectum. So the total length of the latus rectum, remember, is the 4p value. So in our original equation, we had a negative 8 right here. Since it's a length, we just want the absolute value of that. So the length of the latus rectum is 8. So since the total length of the latus rectum is 8, we're going to go 4 units left and 4 units right to get the points on the lattice rectum. So if we count 4 units to the left of our focus, we'll get the point on the left, and then 4 units to the right of our focus. Okay, so then those 2 points on the lattice rectum are going to be -8, -4, and 0, -4. And then just connect your points, and you are finished. And that's going to be our graph. Okay. All right. Let's try another one. So again, analyze and graph the equation. Okay, so first things first, let's figure out the direction that our parabola is opening. So in this case, we have y minus 5 quantity squared is equal to -16 times the quantity x plus 1. So we have a y squared, and we have a negative coefficient in front of our x. So that's telling us that our parabola is opening left. Okay. So next we need to find our p-value. So let's rewrite our equation. So we'll rewrite the -16 as the -4. That's just the constant that is in every parabola. And then in order to get to 16, -4 times 4 would get us there. And we'll still have times the x plus 1. So that tells us that our p-value is equal to 4. Okay. All right, the vertex comes from the h and k. So we have an x plus 1, and we have a y minus 5. So the opposites of our factors, the vertex will be at -1, 5. Okay, go ahead and start graphing this. Let me label my scale here real quick. Actually, I think I'm going to have to use a bigger scale on my y-axis on this one. I'm going to go by 2s. Okay, there we go. All right, so again, our vertex we said was at the point -1, 5. So -1, 5. Let me write around there for our vertex. Okay. All right, then we have our focus. All right, so we said P is equal to 4, and our parabola is opening left. So from the vertex, we are going to go 4 units to the left to find our focus, right? Because keep in mind here that our axis of symmetry is the horizontal line that goes through the vertex here. So along that axis of symmetry to the left, so 1, 2, 3, 4 units left, and we'll have our focus. Okay, so that's going to be at the point -5, 5. The directrix line then is going to be 4 units to the right of the vertex, and it has to be perpendicular to the axis of symmetry, so it's going to be the vertical line 4 units to the left of the vertex. So if we count 1, 2, 3, 4 units to the left, or excuse me, 4 units to the right of the vertex, we'll have our directrix line at x equals 3. Always remember to write the directrix line as an equation. So x equals for a vertical line. All right, and then the last thing we need are the points on the lattice rectum. So the total length of the lattice rectum in this case, look back at our original equation, we had a negative 16 there. So the length of the lattice rectum is just the absolute value of that. So the lattice rectum is 16 units across. So from our focus, we're going to go 8 up and 8 down to get the 2 points on the lattice rectum. Okay, keep in mind that I counted by 2's on my scale here so that we can fit this in. So we're going 8 units up and 8 units down. So 2, 4, 6, 8, 2, 4, 6, 8. Okay, so the points then on the lattice rectum would be negative 5, 13, and negative 5, negative 3. And then just connect your points. And we have our parabola. All right, guys, so I'm going to end this video here. We'll look at one more video with our parabolas, and then we'll be done.